Hey guys, welcome to my channel. So in this video, we're going to learn about another concept of recursion. So this is the second video to the series, Learn Recursion, right? So we're going to compile a program to calculate the factorial of n, and in that process, we're going to learn the new concept called the recursion leap of faith, or trusting your recursive calls, right? So before we do anything, let's just see the code of this simple program counting factorial of n, right? So what we're doing in here is, by the way, if you're not understanding any bit of this video, just refer to my last video on recursion, which is also the first video. In there, I talk about the call stack in detail and also about the base cases and why we need it and whatnot, right? So please refer to that video if you're not understanding any parts of this video. So let's get back into the program. Now, so what we have in here is, it says if n is equal to or less than 1, we're just going to return 1. And we do this because we know the factorial of 1 or 0 is 1. We know that, right? So that is our base case. Now, or else we're just going to return, I mean, in here we can see that we're calling ourselves again. So we're just going to return n multiplied by factorial of n minus 1. So what does that mean? We know that from if you've paid attention in your math classes, you know that factorial of n, so f of n, of any number n, is equal to n multiplied by factorial of n minus 1, right? So what do I mean by this? So let's take an example. So factorial of, let's say 5, factorial of 5 is equal to 5 multiplied by factorial of 4. Simple, right? So if we can figure out, if we can find or get factorial of n minus 1, we can just return, we can just return n multiplied with that data, right? And you must be thinking, wait, is that how it works? Like, it doesn't make any sense. Like, it's gonna call itself, and then it's gonna multiply with n. Like, what if n is like not 4? If we enter 5, what if n is like not 4? What if it becomes 3? I know. So let me guide you through the recursive calls, right? So we're gonna make it as quick as possible because I went through this, and and that's why we need the recursion leap of faith, because that makes it so much easier. And by the way, we use recursion because it's easier to code and it makes our life simpler, right? But if it makes our life harder and if we have to think about every single step and every single call, then it's counterproductive and we don't want that. So that's why we need this, right? We need this concept kind of fit in our head so we can just code recursive functions just on the go, right? So let's look at the recursive calls now. Before we do that, let's try to kind of code out the function itself, right? Why not? Then we'll understand it even in a better way. So first, there's only two lines essentially. I mean, one line because the other one is just a base case, but you get the point. So let's do the base case. If n reaches less than or equal to 1, we're just going to return 1 because it is the base case, and we know that factorial of 1 or 0 is 1, right? We know that. Now, otherwise, we're gonna return n multiplied by a factorial of n minus 1. That's what we're gonna return back. So let's see if it's working or not first, right? So let's print out factorial of 5. It's gonna be 120, right? So yeah, it just did the correct things and gave out the right answer, but how did it work, right? We don't understand that. So let's try to understand it. So I'm just gonna make a call stack now to go over every single step. Let's try to make it a little bit better. I hope I don't even like make it worse than before. But this is, I think this is doable. So we're just gonna make the function calls. Now, obviously, we're gonna have the main function in here already, but we're not gonna make it because we're not gonna bother with that. We're just gonna start from the first function call, which is gonna be when n is equal to 5, right? So function and 5, right? So this is getting called now. So what does it do? It goes to here. It says, well, it says to me that if n is less than 1, I should return 1. I mean, not less than 1. I mean, it can also be equal to 1. I should return 1, but I'm 5 right now, so I don't have to do that. So what is it saying here? Oh, it says that I should return this, like n multiplied by factorial of n minus 1. Wait, I don't know what this is, right? Yet, so I should call it before executing the whole, before returning the value, right? So I'm just making, it's not exactly how it is, but you know, I'm just making it simple to understand. So it says, okay, let me call this, right? Because I need this in order to return the data, right? So now, because of this, another function gets added to the call stack, which is gonna be, you guessed it, factorial of 4, because n minus 1 factorial of 4 gets added to the call stack. And it does the same thing. It goes to here. Well, I'm not equal to or less than 1. I mean, I'm not small. So I have to do this. Oh, it says n, which is 4 right now, multiplied by, I know n, but I don't know this. I don't know factorial of n minus 1. So I have to call that function. So in that way, factorial of 3 gets added to the call stack. Why did I make it so long? Anyway, factorial of 3, again, long, but you get the point. Factorial of 3 gets added to the call stack, right? Now, the same process repeats itself again until we reach a base case. So it's going to be function of 2, and factorial of 2, then it's going to reach finally factorial of 1, right? Of 1. And now, when it reaches factorial of 1, it knows that, wait, I am finally 1. What am I supposed to do now? Oh, wait. The first line literally says what I'm supposed to do. I'm supposed to return 1. Okay. So let me just do that, right? Well, I mean, yeah. So he just returns 1, factorial of 1, because that's a base case. He returns 1, comes to here, right? And now, factorial of 2, you remember that factorial of 2 had this kind of not in its data set? It wanted factorial of n minus 1, which is factorial of 1. Now factorial of 1 just returned back the data of itself to factorial of 2. Now it says, I have the data. I mean, by the way, this is going to get erased just after it returned it. So it's going to get erased. I'm just making it simple to understand. Now it's going to come to factorial of 2 because it's in the stack. And it's going to be like, I have the data now. I have the data of n minus 1. So what I have to return, I have everything now, right? So I have factorial of n minus 1 and I have n, which is 2 myself. So I'm just going to return. So 2 into factorial of n minus 1, which is 1, which we just got returned. 2 is just going to return 2, right? 2 factorial of, you guessed it, 3. So it's going to return 2 to 3. And 3 is going to be like, this thing was supposed to be delivered to me. Now it is. Factorial of n minus 1, which is factorial of 2, has been delivered to me. Now I can use this to return my value and get wiped out of the call stack. I mean, I hope they don't say those things, but you get the point. So it does the same thing. So factorial of 3 returns 3 multiplied by factorial of n minus 1, which we just got returned as 2. So it returns 6 to, you guessed it again, factorial of 4. So it returns 6. And factorial of 4 now has, I just got this factorial of n minus 1, which is factorial of 3. Factorial of 3 just calculated itself and returned me back a data, which is 6. So now I can calculate myself and return this myself, which is n is 4 right now, and factorial of n minus 1, which just got it returned back from all of those recursive calls. And now we have 6 into 4, 24, returned back to the main function. I mean, not the main, but the first call, which is factorial of 5. And factorial of 5, remember, at first it needed n and factorial of n minus 1, and it was like, hey, I don't have this. So those calls got taken into place, got into the call stack because of that. Now, finally, it has the answer of n minus 1, I mean, factorial of n minus 1. Now it says that, okay, I got 24 returned back to me from all of those calls. And now I can calculate my answer. My answer literally says that those answers that I just got returned back multiplied by just myself, which is 5 multiplied by 24. And if you know maths, you know that it's 120. And that's how we get our answer. Simple, right? So we just went through all of the recursive calls. And we just kind of saw what goes on and how recursion works again. But we don't want to do this all the time. We want to have something in place to make things easier for us. So we just have to think of it like this. Whenever we do a recursion call, we just have to think of a base case from where we can get the first data, and then what we have to do is we have to trust a function in a way that it will return us back a value that we need in order to kind of calculate the first term, right? So in this case, it says we need, in Factorial, it's basically like n multiplied by factorial of n minus 1, like, right? So we have to have a faith in our function that our function is going to return back this value, factorial of n minus 1, and then we can multiply it with ourselves, which we have right now, and we'll get the answer. Now this will get recursively called, and how many times it is required, but we know that that after it is done, we'll get our answer back. So this is called the recursion, or the recursive leap of faith, and this is what we need to have in ourselves in order to code recursive functions efficiently and not worry too much about what goes on in the call stack and whatnot, right? So that was it, guys. That was basically it. And if you couldn't understand this, just replay this part of the video a few times and try to understand what went into the call stack. We basically are trying to terminate the process of thinking too much about what goes on in the recursive calls and the binary tree that, not binary, but like anyways, it can make any kind of tree, but the tree that it makes. We're just trying to not think about that and make the process simpler. So yeah, that's basically it. And if you found this video helpful, give this a like, subscribe to my channel, and have a great day. Thank you, guys.